So let's hide everything except our character to have a size reference. And in our instance sources collection, add a collection for our trail signs. Inside it, you can add another collection for the signs itself. First, let's make a post to support the signs. And I will also add the small green part on top. So duplicate this, scale it down, just like this. Shade auto smooth, and let's add the bevel modifier. Regarding materials, we can start with our plank material, duplicate it for the posts, and with a secondary one for the green sign, which you can apply to this object. Now the material for the post is looking pretty great as of now. I will also slightly change the color, so it's more of a greenish hue, and for the sign, a simple green glossy material will do. And this looks nice. Okay, now let's create a sign. Add a cube and move it to the signs collection, scale it way down, make it longer along a single axis, and scale it down on the Y direction. Now still in edit mode, we can move it so it will be instanced correctly on the post without needing too much math. Let's create a sign material. So we are looking at a bright yellow orangish hue, and let's make the side dark with a second material set to dark, and just selecting the edges and assigning it. Right before that, I can add the bevel modifier with the material index set to 0 and something like this. I will make a second copy for the other side, just like this. And now let's use a simple trick to instance them. If in the geometry node system I will spawn points everywhere, it will be really hard to just choose from 3 different location possibilities at the top. So a simple solution I found out is to just duplicate a bunch of points, merge them at centers, so we are sure it's really at the center of everything. And on the side view, I can just place them everywhere I want to instance a sign. Now I can select them and add them to a vertex group called instance locations. With the weight set to 1, click assign. We'll be able to move them later if needed. Let's quickly set some viewport display colors for all the new materials. And let's make a quick geometry node setup to try the instancing of the signs. Bring in the sign collection with separate children, instance on points, with the selection being a named attribute called instance locations, and our instance like this. Now we can join everything, and with some random value set to vector, it will be pretty easy to get some really random signs. I think they are a bit too far apart, so I'm just going to scale everything down like this, delete this setup, and go back to our signs because I just want to add some custom textures. So I made this texture sheet to hide callouts to my social networks and those of NVIDIA Studio. Then I mapped a single face of my 2 signs on the first position of each direction, and using a random value in the object info node in the shader, I am able to switch between different moved coordinates to randomly select one of the 3 different options. With our sign made, let's go back to our terrain. We'll first do a chunk selection just like for the bridge, with a certain probability threshold, so we can duplicate those nodes, and we can select our points from the soil points. Now let's combine this to another filter, because we don't want our sign to be too close to the character or the edges, and we could also just want the sign to be on the opposite side as the character if the camera is always on this side. So let's take the position along the x-axis and compare this to some value with a threshold. So I will select my candidate points from this band. I can add this to the math end operation for the points. Next, we don't want the sign to spawn on the bridge. So let's add another condition with the named attribute linked to the biome, and let's make sure it's not equal to 1, which is our ID for the bridge biome. Now to select a single point per chunk, we would have to know the index of each point inside each chunk, but right now the index node just gives us the index on the overall collection, but you can use the accumulate field node, which allows us to accumulate different value per group. In this case, a group of objects will be a chunk, so if you plug in the chunk ID into the group ID and take a look at the trailing value, if we set this to an integer, we will have the same effect as the index, but with the index starting at 0 for each chunk. Now we can compare this to a random integer value. As of now, the random value will be chosen per point, but if we plug our chunk index into the IDE, it will give us only one random value per chunk. And these small node groups allows us to pick only 1 point per chunk. We can combine this with our chunk probability. Now, because all this is dependent on the selection we did before, we need to apply this as a different separate geometry node. Like this, we only get a few points. Right now, the probability is way too high, so let's lower this to only get a handful of points. Now let's begin to instance or assign. Add an instance on the points node and an object info node. Here we want power posts set to relative, and you can plug that in here. Now for the sign itself, we need to realize the instance to have access to the spawning points we made before, which you can separate with a separate geometry node, and selecting, just like we tested before, the named attribute, which is instance_location. Now we can add another instance on points node, with the instance being chosen from our sign collection set to relative, separate children, and here we need to pick instance. Now we can join this with our posts, just like this. Let's join this with everything else. Let's apply some random rotation, so it's kind of facing the camera, but not too much, just like this. Let's delete some instancer points, so not all the signs have the same number of yellow signs on it. For this, we can add a delete geometry node right before the instancer, and for the selection, we're going to add a random value between 0 and 3 because we have 4 points. Compare that with a less than operation to an index, which we first need to capture. So let's tidy this up a bit. And now the next step will be to make it appear and disappear. Let's bring in our master scale value. Right now it's a bit too sudden because we are on the side of the chunk. So what we can do is offset this value. To do that, we can unclamp the map range, which drives the master scale value, and take this as our post scale. And now we can just add a value to offset everything and make sure to check clamp so that we have no scale bigger than 1 and no negative scale. Right after this, we can also add a float curve to make everything a bit smoother. With an offset of 0.5, it's already a bit better because the post starts a bit sooner. Now let's clean this up. So here, both for the bridge and the post, we have the same kind of node setup. First, we input a curve on which we selected some points and a master scale value, and we output our bridge. And for the post, it's the same but with points. We input our selected points and a master scale, and we output our posts with the signs. So we can just group everything after the point selection. Ctrl G, we have our points and master scale, and the output is our signs, and this is the signs instancer. Now we can do the same for the bridge. Select everything here, Ctrl G. So here for the bridge we have our input, which is a curve. The X is the chunk size from the group input, and we have our master scale as usual, and the output is our bridge. So this is already way cleaner. Now a quick word about optimization. Here we have a bunch of instances which have the scale of 0, which means that we don't see them, but they are still here in some way. So in the end, we can just add a delete geometry node, set this to instance, fetch the instance scale, and compare this with an equal value. We can set this to length, because in our case the scale is almost always the same on each axis, and with this setup like this, we should win a few FPS. Now let's make a simple tree about the same way. Let's first create some leaves. And here is the final setup for my leaves. The models are quite simple, and I use auto smooth and some creases to create a fold in the middle. I also added stems and made sure that the origin of my leaves is at the tip of the stems. Regarding shading, the base setup is quite simple. I used a random value from the object info node into a float curve to change the distribution, and then in a color ramp to have some different color variations from yellowish to greenish. And then I also mapped a leaf picture from pixels onto each of the leaves to darken some part of the leaves with a multiply node, and I also use this to drive a bump node and give some surface variation. And finally, I added a bit of transmission to emulate the scattering on real leaves. And now for the final tree setup. First, the point selection is about the same as for the post. I just added an absolute node, so we have two bands of possible points either side of the character instead of just one. And I created the whole setup of the tree instancer inside this node group, which works the exact same way as the signed instancer. So we input a selection, a seed for the chunk index, and a master scale value to get the growth of the tree when the character is moving. Now let's dive into this. So as you can see, the setup is quite extensive, but by breaking down in several steps, it's quite easy to follow. The first step, once we receive our points, master scale and seed, is to store and compute a bunch of attributes that we'll use later. First, I am storing the seed, so I am sure I have a unique value for each tree, even if we have multiple trees in our scene. Then I am capturing the position of our points, which will be used later to compute noise values based on the position without it changing when the tree is moving. Then I am capturing a tweaked value of the master scale. This is mainly because the master scale is evaluated for each point, so if I am not capturing this attribute at the start of this setup, we may have different master scale values for different points of our trees. For example, in this case, we would have a master scale value of 1 for the base of the tree, which is in our island, but the branches which are overhanging quite a bit would have a master scale of 0. And for this, just as with the post and sign, I am just multiplying it and adding it so I can offset the value a bit and have the tree growing a bit before the rocks and everything is growing. And then the fourth attribute is pretty important. It allows me to compute an index value for each point of the tree and have this value and have this be constant no matter the number of trees we have in our scene. Without this, if we have two trees, for example like this, where we'll have one tree here and one tree here, the index of each point will be computed globally. But with this accumulate field, each tree will have its own set of index, starting from 0 and to whatever value it is. Then the core principle of my tree instancer is to take a curve and instant it over itself a bunch of time, like you can see here. So for this, I am first creating a kind of unit branch with a simple curved line of length 1, which I am resampling a bit to have a bit more geometry to work with. And this is just personal preference, but I am setting the spline time to NURBS, so it kind of computes the value differently when we are making the render. I am making this unit branch of length 1, so I can change the length of every branch and the trunk itself as I wish, just by scaling everything, instead of having to resample or trim the curves or anything else. Here, our geometry flow is splitting into two branches. The one at the top is just here to make the roots, and the one at the bottom is here to make the trunk and the branches of the tree, with the final step to add some leaves. The two setups are exactly the same. I am just flipping my first branch to get to the roots, whereas for the other, it's still in the upward direction. And everything is dependent on my branch instancer node group, which is used a bunch of times. So I will be getting into this now. But first, for a general setup of this, for my roots and my branch, I am just instancing my branch over itself 3 times. So the first time, we have the base of the trunk and the main root, which are just instanced over the points of our mesh which we selected before. So those are the points that are plugged into our node setup. Then I am instancing more of those branches with different scale values and rotation on the top of the trunk. And it's the same for the roots. So those are the main branches and main roots. And then I am adding even more smaller branches on which I will instance the leaves. As for the roots, the final roots will just have very small radiuses. So let's have a look at my branches instancer setup. As you can see, the first 5 values are the same as input and output. This is not really needed because I could have the ID and seed plugged like this each time, but I just find it easier and cleaner to chain the node groups like this. Then on each group, we are going in with the points on which we wish to instance the instance, and the third input is just here to get the previous instance setup so I can combine it with the new instances at each iteration. So for example, the instance itself is the same each time, but at the first step, the instance is just a big version of our branch, is the new branches themselves, and the same for the third step, while the combined value gives us everything combined iteration after iteration. Then on each setup, I have quite simple random rotation and random scale inputs, which I can tweak for each iteration, so I can get branches that are pointing more or less upwards and more or less in one direction or the other. Here, for all my branches and my roots, I am always making the z value go from -pi to pi all around the tree, and the x and y rotation are just from -pi/2 to pi/2, which gives us the top hemisphere above our tree. Then the scale is pretty explicit, and as we set our unit branch at the instance with a length of 1 meter, those are actually meters. So for example, with the first node, I am telling my tree to be always from 4 to 6 meters tall. My second branches will always be from 1.5 meters to 2.5 meter longs, and so on. Then the two next values, the ground distance offset and radius scale offset, are here to change the values that will be computed automatically by my setup for each iteration. So for example, I'm just offsetting the radius that I will compute for each iteration individually. And for the ground distance, I just want to introduce a simple concept, which is that with this setup, because I want to create a tree growth animation, I will want to trim the curves one after the other. For that, the easiest solution I found is to have each branch know at which point on the previous branch they are spawned, so each point will know the exact distance that is separating it from the ground. That way, when we trim the tree by the top, everything will grow down, and so on. And just to have more control of this, I put a simple ground displacement offset, which allows me to offset the values of some branches if needed, and basically make some branches believe they are higher off from the ground than they really are. Then the selection input is just here to select the points on the previous iteration on which we want to spawn our points. So for example, for the first iteration, where we have our main trunk, I am selecting all the points that are above a certain height, which I set to be between 1.5 and 2 meters, so that I am sure that all my branches will be above the characters. And it's the same for the branches that will host the leaves. I am just spawning them in a way that are not too close to the trunk. And for some other values, I am just randomly selecting or deselecting points if I want more or less leaves. And the final parameter, which is pick instance, is just here for me to know if I am picking the instances from a collection or if it is just a single instance. And it also allows to choose if I want to realize the instances or not, because we want to realize the branches as we will displace everything later, but the leaves I want to stay as instance because there will be a bunch of them. Now with all this explained, let's have a look inside this node group. As you can see, it's pretty simple. Everything is based on an instance on points node, and all the random values are plugged in as you would expect. So the random value for the scale takes in the scale min and scale max, the same for the rotation. The pick instance, selection, points, and instance are plugged as you would expect also. One very important thing to note here is that I am plugging both the ID and the seed value into each random value node, whether they are inside this node group or over our whole setup. This allows me to control the randomness and have it stay consistent over the whole animation and not have everything jump when the tree is changing chunk or so on. So for the whole setup, the ID takes into input the accumulate field at the beginning of the setup, and the seed is just the capture attribute seed from our chunk. Then once everything is instanced, I am realizing the instance if it doesn't come from a collection with my pick instance parameter to switch between those two setups. At the end, I am outputting the new instances, the instance itself for the next iteration, and a combined version of our points on which we will instance everything and the new instances. And right before that, I am computing two values, which is first just storing the radius scale offset as I explained it before, and the very important one, which is the ground distance, which is simply computed for each value with the previous ground distance on which we add the current length of the points on which we are instancing everything. And it's here that I am putting my ground distance multiplier offset to have more control over everything. So for the trees, I have everything set up like this. And before spawning my leaves, I am just resampling the curves so you have a greater density of points on which to spawn way more leaves, and the selection values are computed like this. For the roots, the setup looks like this. So it's about the same, but I am flipping the first branch distance as you can see here. And obviously, the selection are a bit different, and the scale min, scale max also changes. Then, once this is computed, I can join the roots with the tree itself. After this, I am doing a curve resample, so I have a bit more geometry to work with before changing the position of everything based on some noise value to get a more organic tree. Two things are to note here. First, the captured position from the beginning is used here to be subtracted with the position of each point, and this allows to compute the noise texture relative to each tree and not relative to their world position. For example, if I am just plugging the position inside here and playing the animation, the tree will warble as it is moving, but as I am subtracting its position, it will create its own local position space for us to compute the noise, and this results in a stable tree along the animation. I set it to a 4D noise, and for the W, I just plug the seed value from our chunk, which allows each tree to be different from another tree, and here you can play around with the scale, detail, roughness, and distortion to get the result you want. As usual, because the values are outputted from 0 to 1 on each channel, I am subtracting 0.5 everywhere so it's centered, and I am scaling it to get the result I like. Then I am also scaling all this noise, because I don't want the base of my tree to be displaced too much, so I am using the ground distance attribute we created before, which is basically 0 at the place where the tree is instanced, so you have about 0 displacement at this point, and more the higher we go on the tree. I am using some map range values like this, and this also allows me to apply different noise values or noise strengths to the roots than for the top of the tree, just as you can see here. So after this step, our tree still doesn't have any thickness, but looks way more organic. Then the next step involves a bit of math, but it allows for our tree to grow during the whole animation, just as you can see here. This is based on a trim curve node, so I can trim off the curves and simulate the growth, and scale instances, so I can just scale in and out the different leaves. So let's have a look at the computing of the trim curve and the scale for these instances. The two are about the same, but we are just clamping the value for the scale instance, so we don't have instance with the scale below 0 or above 1, while the trim curve is kind of auto-clamping. I'm trimming the curve with the length instead of the factor, because everything is kind of based on the ground distance. The first 3 nodes here are kind of here to compute the upper bound of the height of the tree. I'm using a random value to select the max tree height for the trunk between 4 and 6 meters, and those are the same parameters I put on the first iteration of our branch instancer, which I am multiplying by 4 to just take into account the different branches that are instanced over themselves and kind of have a margin. And I am mapping this to the master scale value from before, which is just a value between 0 and 1. And I am just subtracting from this the ground distance value from before, which has the effect of trimming down every point which are further than the distance we created with this node here. Then here the multiply add node and the 2 switches here just allow me to fine tweak everything and get results which are closer to what I wanted. I am just using a switch node so I can use different multiply and add the values for the root and the tree itself. And here I just fine-tuned with trial and error so I can get a growth that I like. But feel free to experiment with that. So after all this, we have a growing tree, and now let's set its radius. I will go over those 2 steps at once. So the second one is just your traditional curve to mesh based on a curve circle profile curve, which allows to convert a simple curve on a 3D object, which is perfect for our tree. And before this, I am setting the radius of everything. So let's quickly decompose this. If I were to just plug in the factor, then we would have a radius of 0 at the start of each spline and a radius of 1 at the end of each spline. So obviously for this, the first step would be to invert it. Like this, it is starting to look like a tree. Now just to have a fall-off that I like better, I like to add a float curve before the map range node, which is just flipping the values. So I kind of have a sharper root, which has a fall-off which looks more like this, and not just linear along the roots. Then I am scaling this value with the radius scale offset we implemented in our branch instancer, which allows to get finer radius values for the thinner branches at the end and before the leaves, and also for the final step of the roots. And I am also multiplying this by our ground distance, which allows to get continuously thinner and thinner branches the upper we are from the ground. But at the factor, it works in reverse, so you have to first use a map range node to reverse this value, and here the 4 max value will just be the max height for the tree, and just to make it simpler, I am computing this with the length of the spline multiplied by 4 to have a bit of an overhead, which gives us this simple setup to compute the radius of the tree. And as you can see, it looks pretty great. And now the final step of our tree setup is just to add a bark material only to the trunk itself and the branches, and not the leaves. So for that I am just separating different components so that I am adding the material only on the mesh and not the instances. And let's have a look at this material. Here the setup is pretty simple and works about the same as the planks and the post and everything else we made around the wood. So I'm using different noise values with the values crunched to get different effects. Here to have a more organic look, I'm using a Voronoi texture which is distorted using a noise texture. Here is the original Voronoi and here is the distorted version. And those values are driving bump nodes on one side to give a bit of a texture to the trunk, and also some mixed color node going through the usual variations with some noises and ambient occlusion to get darker values. The final 5 nodes here are just a late addition to give some transparency to the roots, as in my mind those usually look more like this. So I'm just taking the points that are below the ground to give them a bit of a subsurface scattering value, and the color is kind of a brownish red. And this gives us the simple result, which is not the most realistic and the best looking, but for our purposes and within the animation and everything, it allows us to get a pretty nice procedural system quite easily. Back into our geometry node setup, once we finished our tree, just as usual, we can join it with the rest of our setup, which gives us this render when we are running everything. And that's it for this video. Hope you learned something here. In the next one, we will build on the base biome system to add the 2 new simple biomes. Feel free to reach out to me if you have any question. Thank you for watching and see you next time.